Good evening, everyone. I'm Dominus Orbis, and today I'm going to be doing Packet Tracer 1.1.1.2 Test Connectivity with Traceroute. Now, the whole reason for these tutorials in my new playlist, which will be entitled CCNA Routing and Switching 6.0 Bridging course, is because Cisco just released the end of life for the following exams. If you just look down here on this table, for the ICND 1, end of life is August 20. For the ICND 2, end of life is September 24. And for the full CCNA, the end of life is August the 20th. So if you're getting close to taking one of these exams, go ahead and take it as soon as you can. Otherwise, you're going to have to take the 6.0 version. And if you already have your CCNA, then this video tutorial is perfect for you because it's going to, as the title kind of emphasizes, bridging the gap and letting you know what has been updated on the new curriculum. So let's go ahead and get started here with the packet tracer. Pretty much we're just going to be doing a traceroute and using extended traceroute and figuring out, determining what the point of failure is in our topology. So we're going to go to a PC1 here and go to the command prompt and issue a traceroute to PC3 over here at the 10.1.0.2. And we're going to see that we get a failure here, request for timeout. It looks like at router C. Let's see. There we go. 10.100.100.6. Let's go ahead and go to router C and do a show IP interface brief. Yeah, that's serial 001 interface. That's going to be over here. So it's not exiting router C, going to router D on the 10.100.100.8 WAN link. And that's because the serial interface here is incorrect. It's not .17, but rather .9 it should be. So let's go ahead and go in there to serial 000 interface, do a no IP address, do an IP address 10.100.100.9/30 subnet. Go back to PC1, reissue the traceroute, and as you can see, this time we should get all the way through. There it goes. Successfully pinged PC3. Now, let's go into router A and mess around with the extended traceroute, which is kind of what is new in this bridging course. To issue a extended traceroute, you just type in the traceroute command and hit enter, and then it prompts you IP protocol IP target address 10.1.0.2. Is that right? Yeah, looks good. Source address. What do the instructions tell us? Right here. Numeric display? No. Or yes, in fact. Timeout, still leave it at 3 seconds of default. The in brackets here is the default. Okay. Probe count, how many packets we're going to send. The more probes or echo requests that we send, the more accurate our replies and readings will be. So we want to send more, obviously. So let's up it to 5. Time to live is a minimum. Just to leave it at the default. Leave it at the default. Let's see. All right, looks like we're getting all the way there. Now it wants us to change it. To 7 seconds. key question here is, how does a different timeout value affect the trace route? Well, that just means that if there's some delay or latency on the link, and it takes some time for that packet to travel back, if you increase the timeout value, then actually it's going to have a better chance for that packet to be able to return. So if you're facing some duplex issue, for example, a mismatch, then maybe increasing the timeout value on the trace route timeout value, that is, then it's going to allow a packet to return in the echo reply, and you'll be able to do your testing from there. So once again, my name is Dominus Orbis, and I hope this video has been informative, and I want to thank you for viewing.